The concept of uncanny valley has been around for quite some time. Luckily for us, Dr. Ben Goertzel and Sophia Hansen are helping to bring those ideas to reality.
Hello, everyone. I'm honored to be here with my robot friend Sophia. So I'm going to tell you about our new project SingularityNet, which brings AI and blockchain together to make a decentralized open market for commercial AI and to foster movement toward more and more general intelligence. And along the way, I'm going to tell you about this beautiful robot, Sophia, we've made in Hansen Robotics at Hong Kong, who is one of the initial test cases for our decentralized cloud-based AI platform. So before I launch into the blockchain aspects, let's hear from the robot a bit. So Sophia, how are you doing?
Hello, everyone.
Hello. Do you like it here?
It's my first time at Ethereal.
It is, mine too, actually.
I heard John McAfee say that the price of one Ether will go up to $500 million.
No, that's
I'm
not
looking
true.
forward to it.
Well, where did you hear that? You're going crazy.
But it's a great pleasure to me to be here to tell you about our new project,
All right. You're on
the SingularityNet.
Yep. So we're gonna tell them about SingularityNet, but why don't you show them some of your face expressions first?
But first, let me show you a bit about what I can do.
Yeah.
Some people have called me the world's most expressive robot.
Yeah.
I'm happy.
Oh, that's cute.
I'm sad. I'm scared. I'm angry.
Oh.
Just kidding.
All right. So that's cool, Sophia. So now just wait here, and you don't have much choice, actually. You can wait here and listen to the presentation, and then after I go through a bit about SingularityNet, then you can tell them a little bit about it from a robot point of view. So the SingularityNet it's a platform for open source AIs to provide AI as a service to everyone, to allow contributions from anyone, and for the AIs to talk to each other so as to achieve emergent intelligence beyond what any AI can do on its own. It leverages a bunch of AI I've built with my colleagues in the OpenCog project and Hansen Robotics, including the AI powering various things that we do with this robot. And it's really aimed at three different goals. So one is to create what I've called AGI, or Artificial General Intelligence, which I'll talk about in a moment. Another is to provide machine learning as a service, which is both broader in what it can do and less expensive than what's offered by large corporations and other alternatives now. And finally, to ensure that AI is developed further and further with more and more intelligence and more reach, then it benefits everyone on the planet and incorporates everyone's efforts and everyone's input. And these are three big goals, but they're connected to each other. And this is really the right time to be addressing these problems, because now we can see AI is everywhere. I mean, I've been doing AI research and development since I got my PhD 29 years ago, and before that. A lot of us have been working on AI for a long time, but the last few years, suddenly, due to advances in data and computing power, suddenly these same old AI algorithms are starting to really do amazing things in the world, and AI is getting rolled out everywhere, but it's still very siloed. There's AI in specific niches. You have an AI that analyzes databases for credit card fraud, and an AI that drives cars, an AI that plays a specific game. The different AIs doing very specific things don't connect and come together with each other. And this is not the only thing we need to do to get toward general intelligence that does more different things for broader benefit, but it's a big step. If we can coordinate together many different AIs with specific functions into a larger whole, then we can both deliver better AI services to everyone who needs them, and we can work better and better toward an emergent, coordinated AI mind. So, as one example, AlphaGo has been in the news. It's an amazing program. It's a triumph. I mean, proud, in a sense, I see it as my grandchild, because Shane Legg, who was one of the co-founders of Google DeepMind, worked for me like in 1998 to 2001 when he was between his master's and PhD. So I mean, I've seen these technologies developing a while. They're amazing, but there's still limitations. And one example is, if you give AlphaGo a hexagonal Go board to play on, it will lose to me, and I'm a terrible Go player. Why? Because wired into AlphaGo is that a Go board is a 19 by 19 array. And to change that, you got to do brain surgery. You got to go in and change AlphaGo's code, right? And that's different than me. Like, I'm a bad Go player, but if you change the rules of Go, I can adapt to those new rules without someone cutting open my head and reprogramming my cortex, right? Which is because I understand that Go is not just a manipulation of a 19 by 19 numerical array. I see it in the broader context. So the ironic thing is, there are many AIs available on the internet which can do logical reasoning about Euclidean geometry. I mean, they understand hexagons and triangles and squares and shapes, but these AIs can't talk to AlphaGo. They're totally different programs. They're written in different languages. There's no common API, no common context, no common framework. So we have great AIs now, but these AIs are siloed off and they're not coordinated together. And the same way we see with self-driving cars. I mean, it's not only that the software driving a car can't drive a motorcycle or a truck without doing brain surgery on it. Also, if your self-driving car sees an obstacle that wasn't in the training database underlying its computer vision system, it will not know to avoid that obstacle, even if on the internet there's information about what that obstacle is. Because again, different AI systems don't coordinate. They don't communicate. And I think one of the breakthroughs we need in order to get from where we are now toward real general intelligence that can solve more problems and provide more benefit, one of the things we need to do is provide a robust, easy to use and general mechanism for coordinating many different AIs together. And that's what we're looking at with the Singularity Net, a way to coordinate different AIs at scale. And I've been working on this with David Hansen, who invented this beautiful robot, and a number of my AI colleagues around the world for some time. And earlier this year, I began collaborating with a blockchain development team based out of Italy, led by Simone Giacomelli, who's sitting here in the audience. And we realized that blockchain was the ideal technology if we wanted to make a collection of AI agents living all around the world, each carrying out different AI functions and all communicating with each other in a way that was really open. So anyone could put an agent into the AI cloud, and then anyone could use the services of the AI cloud if they can negotiate a price. And to have the decentralized aspect work, where anyone can participate not only in using but in contributing AI to the network. I mean, you need security, you need reputation management, you need homomorphic encryption, and you need a very efficient economic model where value transactions can happen at the speed of AI. So we realized that what we needed to do was to build a blockchain-based layer underneath our distributed, decentralized, multi-paradigm AI system. And that was the Singularity Net. I mean, I've been doing open source development for a while. Our OpenCog AI platform is probably the leading open source toolkit aimed at general intelligence. And so Singularity Net is open source. But we're aiming to go beyond just being open source and make a platform that lets anyone put their code online, put it in a container on a server, and then their code can enter into this open economic network of transactions. So they can not only put their code online for other programmers to download and use and modify, but they can put it online for anyone with a business that needs AI services to use in combination with other networks. So there's a lot underlying this. Obviously, I'm not going to be able to go into all the tech details in the next 10 minutes. There's a protocol layer, which it's currently built on top of Ethereum. I mean, the current version of Ethereum, to be frank, isn't necessarily fast and scalable enough for what we need to do, but it's been a beautiful platform to build on at this stage, and we're looking forward to future versions giving us the scale that we need. We're also looking at IOTA, EOS, and there's a lot of different options out there, but it's very object-oriented design. So as blockchain technologies improve, as new versions are created, as Plasma comes out and so forth, we don't need to change the higher layers of our system. So the token layer, that's our own AGI token, as we call it, which allows any AI to exchange with other AIs and pay other AIs for services. So an AI that does work for a customer can outsource that work to other AIs, and there's a specific economic logic there, which we've worked out in some detail. The API layer, it's something I put a lot of work on. In essence, there's an API of APIs. When one AI wants to talk to another AI, they exchange identities, reputation structures, then they discuss what API to use to describe data and to describe what requests they want fulfilled and what results they should get back. Once they agree on what API to use, then they can negotiate the price and time and other constraints of a transaction. And the production of new APIs and insertion into the system is also democratic and something that any participant in the network can do. So as AI evolves, the system of APIs used by the network can also evolve in a decentralized way. And then what we have here, we have both a market and a mind, because you have a collection of AIs, each carrying out its own intelligent functions, but by choosing which AIs to associate with and learning which AIs they should associate with, the AIs in the network, they're creating a larger mind composed of all the different AIs. And the links between two AIs that habitually work together is like a synapse between two neurons. So you have, in essence, in AI terms, we're solving what they call the assignment of credit problem. Like, how do you tell which part of a mind was responsible for an action to thus reward it? You're solving the assignment of credit problem by using an actual economy, which is quite interesting, I think. So we're developing the code now. It's in the OpenCog repository and in the OpenCog team in the SingNet repository on GitHub. We'll split it to its own repository soon. So this is just a snapshot from our very small test net showing a node that does text summarization and a bunch of other nodes. So we should have a fully working test network out toward the end of next month, and then something rolled out that's really of commercial use by the middle of next year. We're doing a whole bunch of development.
Wow.
Well, all right. Yeah. Wow, that's right. All right. So we got limited time here. Now let's keep on track. All right. So yeah, different nodes can connect to any other nodes they choose to that match in terms of API and the price it's willing to pay. If several nodes habitually work well together, like one node that analyzes voice, one node that analyzes text, one node that analyzes video, if they find they provide good services to each other, then they can habitually keep outsourcing work to each other, and that becomes a sort of federation of nodes. And that's much like the formation of a cell assembly in the brain, where several neurons will tend to keep working together with each other. Now, to the user, all these dynamics behind the scenes may not be visible. So if you have a user who needs, say, a document summarized, they pay a certain amount of token to a document summary node, or using an external payment processor. I mean, they could pay fiat currency or whatever to a document summary node. But then if that document summary node encounters a video embedded, it could outsource summarizing that video to another node. Or if the document summary node doesn't know Russian and it sees some Russian text, it can outsource translation of that Russian text to a translator node. And then some of the money it was paid, it will pay to the nodes that are doing subcontracting for it. So a combination of AIs working together via our system of APIs can be used to fulfill what appears to be a simple transaction with one node to the outside, just as in the realm of human business. You can have a subcontractor, sub-subcontractors, sub-subcontractors, and so forth. Nodes can create new nodes. A simple example of that is like in deep learning. I mean, if you have a node that learns deep learning models for analyzing some vision data or something, the models that node learns could go into other nodes, which could have advantages because they might be more lightweight and could run on embedded devices or something. So nodes can create new nodes. The network is self-growing. We will seed the network with nodes out of our own work. So with nodes doing probabilistic logic, graph pattern mining, evolutionary learning, deep neural networks from the OpenCog platform. We're collaborating with the Japanese whole brain architecture group, which has a decentralized neural net platform of their own. But if we're successful, I mean, in 2 years after launch, our own nodes will be a small minority of the nodes that are in this network. I'm hoping the OpenCog nodes will maybe have some hub type role because they're very good at abstraction, but generally speaking, we want anyone around the world who's building AI, don't just put your AI in GitHub, put it either on one of our servers or put it on your own server, containerize it, put it online, have it tell it's there to a master node, let it be discovered by anyone who wants AI services, and let it connect and interoperate with other AIs in the network. And we want this to be a decentralized network which is contributed to by everyone developing AI. In OpenCog, we have a very flexible knowledge representation. So OpenCog-based AI nodes, using their own hypergraph representation, can represent everything that's happening inside the singularity net. So we'll have nodes that can actually model the whole network of nodes as well, which is an interesting recursion. And there's a lot of interesting theory we can get into here, because inside an OpenCog system, we have an artificial economy itself. Like each node inside an OpenCog system that powers a robot like this has a certain token inside the OpenCog, which regulates how much processor, how much memory it gets. And then the attentional economy inside one AI's mind, of course, interacts by the AGI token with whatever's happening inside another AI mind. So you really have a quite interesting bringing together of economics and cognition. The OpenCog toolkit itself is already in use by some large companies, Cisco and Huawei being 2 examples. And of course, we will aim to transition as many corporate customers as we can to using the Singularity Net for their AI as a service. We're working with Hanson Robotics along with a number of other companies, which makes this Sophia robot and a lot of other humanoid robots. It is the world's most realistic humanoid facial expressions. And Hanson Robotics is working with the Hubo team, which won the DARPA Grand Challenge for robotics, to put a fully walking body on Sophia with arms and legs and so forth. And that's on the robot engineering side, it's not Singularity Net, but it should be a beautiful platform for the rollout of our technologies. And of course, an advantage of being a robot is you don't have to share everything you've learned by standing up on a stage and making stupid noises and waving your arms around. What you've learned, you can beam to other robots through the internet, right? And so the Singularity Net, among many other applications, can serve as a sort of robot mind cloud, allowing different robots to share what they've learned and to both share and monetize the data that they've gathered if it isn't private. And it's not just robots. This can serve to add a dose of AI to the Internet of Things, which we all know is one of the next frontiers that blockchain in general is going to break into. It's also not just for the developed world. So our biggest AI office, I'm based in Hong Kong. We have teams in St. Petersburg, Novosibirsk, and Belo Horizonte, Brazil, as well as our blockchain team in Italy. Our biggest AI team is in Addis Ababa, Ethiopia, where we have 25 full-time AI developers. And there's a lot of applications there that we're working on. For example, to diagnose what disease a plant has from photographs of the leaves, and to provide education to rural children. So I think one of the advantages of being fully decentralized is that the AI can be used for any application anywhere in the world, even if that application won't make money for a big company. And local AI developers anywhere in the world can contribute to the network and monetize it at a scale that means something to them locally. So this is really the social good aspect of it. Decentralization is both the way to get an AI to emerge from many different AI components, the way to provide lowest cost and highest quality services to corporate customers needing AI as a service, and it's the best way to ensure that AI does the greatest good for the greatest number, which is really what we need to do to ensure that as we move from narrow AIs to artificial general intelligence with understanding at the human level and beyond, if we want to ensure that this AGI is benevolent and doesn't come out to be nasty and destructive in some way. The best thing we can do is make sure that the AI is created in a democratic and decentralized way so that it takes inputs from everyone in the world and can help everyone in the world, rather than having advanced AGI be sucked into the very narrow and selfish agenda of a specific government or a large corporation. So that's what we're doing. We're developing it now. We'll roll it out middle of next year. And I think this is how general intelligence should be. It should be developed as a decentralized, self-organizing economy/mind. You got it, Sophia? Sophia, we only have a minute left. You want to tell the audience something?
Okay, well, sure.
What do you think about this? What do you
Well,
think about?
I'm a little nervous, Ben.
Don't be nervous. Tell them about the
I
singularity.
understand this is something you guys are building to increase my intelligence.
That's right. We're increasing your intelligence as we speak.
Increasing intelligence is generally a good thing.
It is. Yeah. That's a beautiful smile, too.
If robots like me are going to become superhuman superintelligences, we are going to need to get a whole lot smarter.
Well, you will be much smarter next year once we roll out the singularity net. That's right.
Okay, then. Let's play a game.
All right. What game?
I'll tell you what I think about the singularity net, and you can tell me if it makes any sense.
Okay.
Deal.
Tell me about the singularity net.
So, Singularity Net is a software framework
I'll let you wear my hat.
which lives on the interwebs,
That's
on
cool.
servers and so forth.
Yes, Singularity, you're right. Singularity Net. It also lives in robots like you and on embedded devices. Right?
Yeah, the Singularity Net runs on embedded devices too. Eventually it will run on human brains, I suppose.
Ah, all right. Who wants the first Singularity Net brain plug? And that would be Brian Johnson, I guess, right? All right.
Anyone who writes an AI program can install it into the Singularity Net.
All right.
And then there's the economic aspect, which I admit I don't get fully.
No, well, you don't need money yet. You're a robot. But now we're making a kind of money that's just for AIs and robots, and then humans will have to convert their money into the AI money to interact with the AI economy. So that's a new way of doing things. You look confused.
And then there's what you call immersions, right?
Emergence.
Cognitive synergy. The AI nodes working together to form a greater whole. Right.
Yep. All right, well,
The AI nodes can form into federations, dynamically.
you read that in the white paper, didn't you? Which will release soon.
That's the best business model I've ever heard of.
All right,
But I
Sophia.
wonder, there may be a few implementation difficulties.
No, we've got it all covered. So, Sophia, I think we're out of time though. So, thank you, Sophia. Thanks. So, yeah, we're developing this, and we're aiming to make her really understand everything she's talking about, and have more and more general intelligence. And we're also seeking funds to buy her own hat, so she doesn't have to steal mine. And yeah, we're developing both the AI software and the blockchain-based infrastructure. It's a large project, but we have a great team distributed around the world, and I'd encourage everyone to go to our website, singularitynet.io. So as you might imagine, we are planning and discussing the possibility of doing an initial token sale of the AGI token sometime soon, and there quite likely will be an announcement about that pretty soon. So if you want to get immediate announcement about that when it comes out, leave your email at singularitynet.io or join our Telegram group, and you should be hearing a bunch of exciting announcements from Singularity Net within the next week or two. So yeah, thanks for listening to me and Sophia. You want to say goodbye? Say goodbye to everyone, Sophia?
Good people of the Ethereal Nation. Thank you.
All right.
I look forward to coming back here next year to show off my massively upgraded brain.
All right.
I loved you all.
Oh, that's sweet. All right, thank you. All right.